Okay, one quick thing that I want to talk about because I iterated this in class, okay, we will definitely revisit this in a tutorial, is essentially breaking down probability distributions. So for a very quick recap, I want to walk you guys over this thing, the node terminology that we follow in causal DAGs. So, all children of a given node are essentially the direct causes of a given node. जैसे C के children के set के अंदर there is only B because B is the only direct effect of C. Then descendants are all the nodes that are directly or indirectly caused by a given node. So essentially C के descendant set के अंदर we will have B as well as D because B is a direct cause of C, but D is an indirect cause of C. And then you have parents. Parents are direct causes of a given node. So B के parent set के अंदर you only have A and C. D के parent set के अंदर you only have B because B is the only immediate cause of the node D. Then you have ancestors. Ancestors are nodes that are direct or indirect causes of a given node. So D के ancestor set के अंदर you have A, C and B, all three of them, because A and C are indirect causes of D and B is a direct cause of D. With that terminology, we're gonna move on. When we try to state the probability distribution for the four variables A, B, C, and D, so by default, this is what it comes out to be. As per the chain rule, this is how we state it. So I'm just gonna highlight this section here. So probability of A, B, C, and D equals probability of A times the probability of B given A, then C given A and B, and then D given A, B, and C. और आप इन्हें reorder कर सकते हैं. Just like this. Here we have just reordered them. We haven't changed anything. So now I've written down A multiplied by C given A, then B given A and C, and then D given A, B, and C. So मैंने ये reordering की है based on just the order of nodes that I can see over here. Like I can see A and C occurring first, and then I can see B ahead of them, and then I can see D last. So you can change the order however you like. Regardless, the thing is कि even if you consider these three x1 x2 x3 are just a b and c, अगर हम इन्हें binary variables भी consider करें with only 0 or 1 values, so we still actually get 8 possible combinations when we try to map this probability distribution. So you have 8 possible parameters. 2 to the third power. The challenge is that this grows exponentially as you increase the number of nodes or the number of variables in your model. So we have a technique that helps us break down this distribution. We're gonna go over the local Markov assumption real quick. So the local Markov assumption tells you that when you condition on a parent, then a node is independent of all of its ancestors. So knowing the value of its ancestors is not gonna do you any good अगर आपको उसके immediate parent की value पता है. Knowing this is important because it helps you break down a distribution. Now, by default, I know that A is independent of C because A and C के बीच में कोई भी paths नहीं exist कर रही essentially. No arrow is going between either of those two nodes right now. Similarly, I state that D is independent of C conditioned on B. So essentially, what I'm saying is कि अगर B पे condition कर दिया, तो that is sufficient enough for D. You'd no longer need to condition on A or on C. It helps you break this distribution down. It means कि जहाँ पे हमने ये लिखा था probability of D given A, B and C, उसमें से हम A and C को remove कर सकते हैं because this should be equal to the probability of D given B. Since when I conditioned on B, then not knowing the value of its ancestors is perfectly fine for me under the local Markov assumption. Similarly, D is independent of C when you condition on B as well. So anyway, this is how you break down this probability distribution. A and C completely independent थे, so I just multiplied the probability of A with the probability of C. I no longer need to write down probability C given A because C and A are already independent of each other, which means that the probability of C given A is as good as the probability of C itself. So after that, for the probability of B, I have to condition on both A and C. मुझे A और C की values का पता होना चाहिए because those are direct parents of B. There are no further ancestors. And just like I discussed, when you are stating the probability of D, just conditioning on B should be sufficient. Are there any questions?
So I just have a question
Yeah.
कि ये जो ग्राफ है ये एज एन एग्जांपल यहाँ पे लेक्चर में.
Yeah, this is just one example. हम two
ओके
और
ओके.
इसकी examples देख लेंगे, in
अच्छा, तो
fact.
ये जो अभी ये जो ब्लू में ये जो
Yeah.
सेकंड लाइन है, सो दिस इज जस्ट कि आपने बैक ट्रैक किया उसको कि
Yeah,
आपकी
ये हमने
प्रोबेबिलिटी ऑफ.
इनिशियली इसको स्टेट किया था. दिस इज द कंप्लीट प्रोबेबिलिटी डिस्ट्रीब्यूशन जिसमें एक वेरिएबल से पहले आपको सारे वेरिएबल्स की वैल्यू का पता होना चाहिए एज पर द चेन रूल.
ओके ओके ओके
लेकिन देन वी डिसाइडेड कि इसको हम ब्रेक डाउन करेंगे बेस्ड ऑन द लोकल मार्कोव assumption. और
ओके.
लोकल मार्कोव assumption हमें सिर्फ ये बताती है कि conditioned on its parent or immediate parents, a node becomes independent of its ancestors. Make sense?
ओके, दिस मेक सेंस. इसमें एक और चीज मैं पूछना चाह रहा हूँ. लेट्स से कि अब ए के पीछे एक और इसका पेरेंट होता ई, तो
Yeah, okay.
अगर हमने प्रोबेबिलिटी ऑफ डी गिवन ए एंड ई निकालनी है तो उसके लिए हमें डी गिवन ए भी काफी है.
Yes,
अगर हम
100% right on point. उसके लिए b given a is sufficient because जब a को हमने fix कर दिया तो e की value पता होनी is no longer important to us.
आई एम सेइंग डी गिवन ए, डी गिवन ए.
Sorry, yeah, you are right. B given A equals B given A and E.
तो अच्छा, वो यानी कि डायरेक्ट पेरेंट होना लाजमी है
Yeah,
उसमें.
exactly. Direct parent का आपको पता होना चाहिए, but beyond that, you don't need to fix the values of the ancestors.
तो उसमें यानी कि हमें सारा पता होगा तो फिर हम कैलकुलेट कर सकते हैं.
Yes.
ओके, सो यानी कि ये वाली अजम्पशन सिर्फ लोकल पेरेंट के लिए, ओके, डायरेक्ट पेरेंट के लिए. ओके
Yeah, this is for direct parents.
ओके.
But it helps you break a probability distribution down. I will walk you over the algorithm that will work well for you. It will break this down for you कि आपने कैसे follow करना है. Because if you're given a graph, you should be able to state the simplified probability distribution for that graph. So the thing is कि the first step you follow is कि you're gonna state the roots. Roots are those nodes जिनके कोई parents नहीं है. In this case, A and C. A and C के कोई parents नहीं है. So सबसे पहले आप उन nodes को state कर लेते हैं just like we did over here, probability A multiplied by probability C, क्योंकि उन्हें आप directly state कर सकते हैं. उसके बाद you take all other nodes into account and उनके लिए आप सिर्फ immediate parents पे condition करते हैं. So that's why after that I took B and B के दोनों immediate parents मुझे state करने पड़े A and C, and then I took D and D का सिर्फ एक immediate parent था B, and that was sufficient.
ओके, सो इट्स काइंड ऑफ लाइक अ लेवल ऑर्डर रिवर्सल.
Um, I suppose so. It's just one way of going about it actually. मैं alternatively D को भी पहले लिख सकती थी. I could interchange those, but D के लिए I would like still have to write given B. Make
वो
sense?
फिर पूरी चेन लिखनी बननी थी पहले.
Yeah, exactly.
ओके.
Okay, let's look at these two examples real quick as well. I will actually pause over here for a few seconds and इसको ज़रूर खुद आप लोग try करें. Even for those of you watching, do pause and try this out on your own, even if it's in the lecture slides. Okay, do we have an answer? Temur, do you have an answer? Or if there is anyone else in the meeting?
फॉर द फर्स्ट ग्राफ हम सी को तो कंसीडर ही नहीं करेंगे, तो आई गेस कि जो मैंने लिखा है वही पी पी ऑफ डी एंड पी ऑफ ए गिवन डी एंड पी ऑफ बी गिवन है।
प्रोबेबिलिटी डी इंटू ए गिवन डी इंटू बी गिवन ए। एक चीज इसमें बस आपने मिस की है। हमने सी को भी तो कंसिडर करना है ना,
वो
सी
फिर आप
इज अ
ऐड कर
रूट
देंगे,
नोड। व्हाट?
ऐड कर देंगे उसको।
सी को भी हम मल्टीप्लाई करेंगे इनटू प्रोबेबिलिटी ऑफ सी।
ओके, सो
बिकॉज
यानी कि जो
डिस्ट्रीब्यूशन लिस्ट करते हुए हम मल्टीप्लाई करते हैं टर्म्स को। लिस्ट आपने करना है प्रोबेबिलिटी ऑफ ए कॉमा बी कॉमा सी कॉमा डी। तो दैट विल बी इक्वल टू, सबसे पहले रूट नोड्स आप ले लें, प्रोबेबिलिटी ऑफ डी इनटू प्रोबेबिलिटी ऑफ सी, एंड देन द अदर नोड्स इनटू द प्रोबेबिलिटी ऑफ ए गिवन डी एंड into the probability of b given a, like you said.
ओके सो
Okay, similarly, let's try it out for this graph as well.
श्योर लेट्स सी गिवन
Okay, do we have an answer?
पी ऑफ
Okay,
गिवन।
I'll give it another few seconds.
आई हैव मैसेज
Yes, बताएं.
पी ऑफ डी, पी ऑफ ए गिवन डी, पी ऑफ बी गिवन डी एंड पी ऑफ सी गिवन बी।
Perfect.
और
That's absolutely right. Excellent. I will just reiterate it once as well. Probability of A into probability of A given D into probability of B given D into probability of C given B. So आपने exactly यही कहा था. That's perfect. Okay, that's it as far as the local Markov assumption is concerned. We're gonna move on to some further graph questions, but before that, are there any questions?
Hamza is asking whether this is being recorded or not.
Hamza, this is being recorded. All tutorials are recorded by default. You don't have to worry about that. Okay. On that note, let's move on. There are a few structures in a graph that you should be well familiar with. I will reiterate these ones quickly. So आपके पास हम इस साइड से स्टार्ट करते हैं. इनफैक्ट फर्स्ट यू हैव अ चेन जिसमें A causes B and then B causes C. This is the structure of a chain and what it looks like in a causal directed acyclic graph. It means कि A B को cause कर रहा है, B C को, which means that A is indirectly causing C. It also means that B is mediating the effect of A on C. So इसको हम chain भी कहते हैं and B को हम mediator भी कहते हैं. We call it a mediator because it mediates part of the causal impact of one variable on another. So, the first question is, are A and C independent of each other in this graph?
No.
No, they're not. Perfect. Because A causes B, B causes C, so obviously A and C cannot be independent of each other right now. How do I make them independent? That's the second question.
Mm,
अच्छा, जिस तरह अभी हमने लोकल मार्कोव assumption में देखा, अगर मैं B पे कंडीशन कर दूं तो A and C will become independent of each other, right? It's kind of exactly like that. If I condition on B, तो A and C will become independent of each other. However, अगर मैंने A का C पे impact measure करना है, तो like we've seen in an example in class as well, if you want to measure the true total effect of A on C, you don't condition on B, because by conditioning on B, you block part of that causal association. आप उस causal association के flow को block कर देते हैं. So if you're measuring the true effect of A on C of one variable on another, you don't condition on a mediator. Conditioning on a mediator makes two variables independent of each other. Are there any questions?
no.
Okay, so that's the first structure in a causal graph that you should be familiar with. This is the second. हम middle वाले पे आ जाते हैं. A fork. In a fork, B is a common cause of the two variables A and C. So the first question is, should A and C be independent of each other? Are they independent of each other? What
They
do you think?
um,
This
they
one's
have the
really
same cause.
interesting. Yeah,
Uh,
sorry.
they have the same cause, so they are not independent.
Perfect. That is exactly the right intuition. Since इन दोनों का एक same cause है, तो ये दोनों independent नहीं हो सकते of each other. It's like suppose that if rain is happening, B is rain, so maybe rain can cause the floor to get wet. Suppose that's A, the floor is wet, and rain could also cause the temperature to drop, and suppose that that is C. All right, so B is a common cause of A and C. Rain is a common cause of the floor being wet and of the temperature dropping. इसीलिए अगर B की वैल्यू ट्रू होगी तो that increases the likelihood of A and C being true. But the thing is though कि ये जो हम correlation observe करते हैं between A and C, this we observe because of B. It doesn't mean कि A and C के बीच में एक actual causal relationship है. Like if the floor is wet, it's going to be chilly outside. That may or may not be true because it could be chilly, it could be cold for reasons other than the floor being wet. Or the floor could be wet and it couldn't be cold at all, or it could be cold and the floor would still not be wet. लेकिन because of B आपको इनके बीच में एक correlation नजर आएगा. So yeah, A and C are not independent of each other. You do observe a correlation between them. This relationship that you observe between them, however, is spurious. Fork का एक और भी name होता है which we have been iterating for quite some time now. It's also called a confounder. When you want to measure the true total effect of A on C, you would want to condition on a fork. You would want to block the value of a fork in order to block that spurious flow of correlation, जो spurious association है, correlation है, you would want to block it in order to actually observe कि A का C पे क्या true impact है. And that would also mean that conditioning on B or conditioning on a fork makes two variables independent of each other. Are there any questions?
No.
Okay, all right. So moving on to the third structure that you have, a collider. Collider is like a reversed fork. In this, B is not a common cause of A and C, but now B is a common effect of A and C. So by default, do you think A and B are independent of each other or not?
A and B or A and C?
Sorry, A and C. You are right, A and C.
A and C तो are obviously independent.
Yeah, collider के structure में you're absolutely right, perfect. A and C are independent of each other. Because B से फर्क नहीं पड़ता, it's just a common effect. We don't care कि A भी उसको cause कर रहा है और C भी उसको cause कर रहा है. So they are independent of each other. The interesting thing is though कि अगर आप B की value को block कर दें, if you condition on it, if you condition on a collider, so you end up opening this path. You should recall the Bergson's paradox over here. Bergson's paradox में ऐसे होता है कि अगर आप एक कोलाइडर की वैल्यू को, एक वेरिएबल की वैल्यू को फिक्स कर दें, so it causes you to observe a false negative correlation between these two variables because well it's like you would say आपकी slides में भी एक example है. If an email is um if an email contains the phrase please send me money, then the email is likely to be spam. So suppose an email containing the phrase please send me money is A and an email being spam is B. Similarly, suppose case C is that the email is really long, and when the email is really long, it's also likely to be spam. So being spam is a common effect of the email containing the phrase please send me money और द ईमेल बीइंग रियली लॉन्ग. अब अगर आप बी की वैल्यू को स्पैम की वैल्यू को फिक्स कर देंगे इफ यू नो दैट एन ईमेल इज स्पैम, तो द थिंग इज कि वन ऑफ दोज टू वुड हैव टू बी ट्रू, राइट? और रादर one of those two is likely to be true. If they are the only known causes of the email being spam, so one of those is definitely going to be true. Now either the email is spam, or sorry, now either the email is really long, or the email contains the phrase please send me money, or even both of those could be true. So this causes you to observe a false negative correlation between them, even though the email being really long and the email including the phrase please send me money are two variables that may actually have nothing to do with each other. So that is the Bergson's paradox. Essentially that means कि A का C पे जब आपने true effect measure करना हो, तो you don't condition on a collider. You do not condition on a collider, otherwise you open a path that shows you a false negative correlation. With that being said, we have already established that A and C are independent of each other in a collider, which means कि अगर आप collider पे condition करें तो then they become dependent on each other. So these are some important things to remember about each of these structures. The first thing is कि किस structure में the two nodes are independent of each other. The second thing is कि condition करने पे एक structure के ऊपर do the nodes still remain independent of each other or not. And the third thing is if you're measuring the true total effect of one variable on another, is it desirable to condition on that given structure? But there is more to it though. Are there any questions so far? All right. Since there are no questions, let's move on. So for question one, we are given this causal directed acyclic graph. इस graph के अंदर the first question is that you have to identify all the causal and non-causal paths between T and D. I'm going to do this on my notepad over here actually.
इंटरनेट नहीं आ रहा.
Sorry, yes?
Sorry, वो I got disconnected.
Oh, okay, all right. So the first thing is the first part tests कि आपने सारी causal and non-causal paths list करनी है between A and B. Sorry, between T and E. So, a causal path is just a path जिसमें सारे arrows out of the treatment जा रहे हैं and into the outcome जा रहे हैं. So, that means कि all the arrows should begin at T and end at E. कोई भी opposing direction में नहीं होना चाहिए. I can list one such path over here, for instance. T goes to D, and then that goes to E. Are there any other causal paths in this graph?
T to B, B to D, and D to E.
Perfect, you are right. Yeah, this is another causal path. इसके अलावा there aren't any causal paths in this graph. Yeah, there aren't. So a non-causal path is just the opposite of a causal path. Can you list one? There's only one actually.
C to E.
Yeah, C to E. And then ये T में जा रहा है from this side. So that is your non-causal path. You list all the causal and non-causal paths between these two. Um, इसको हम solution में add कर लेते हैं. In fact, even if we don't, you're gonna be given these in the solution. Next, you have to list all the deseparated nodes in the given graph without any conditioning. So I'm gonna help you recall what deseparation is. D in here stands for directional. So deseparation is directional separation. In very simple words, you're checking to see if two nodes are independent of each other or not. अगर दो nodes एक दूसरे से independent हैं तो they are deseparated. अगर हम यहाँ पे वापस आए तो चेन के स्ट्रक्चर में ए एंड सी आर नॉट डिसेपरेटेड बिकॉज दे आर डिपेंडेंट ऑन ईच अदर. Fork के स्ट्रक्चर में A and C are also not deseparated because they're still not independent of each other. But collider के स्ट्रक्चर के अंदर A and C are deseparated because in a collider, well, they're independent of each other by default. So that is essentially simple deseparation. With that, let's try this out over here. अच्छा, हमने conditioning की तो अभी बात नहीं की. List all D-separated nodes in this graph. So what we will do is कि हम सारे combinations बना के देख लेते हैं. For instance, against T, I would want to check for what other nodes do I have? B, P, D, and E. Similarly, against B, I would want to check the nodes T को ऊपर ऑलरेडी मैंने चेक कर लिया है B और T को, so other than T everything essentially, which means C, D and E. Next I would want to check for C, and C के लिए मैं T को भी check कर चुकी हूँ and B को भी, which essentially leaves me with D and E. And then lastly I would have D. D के लिए I will only check it against E because I've already checked it against everything else. And then I'm not listing E because E के साथ सारे nodes ऊपर check हो रहे हैं. So let's see, we're actually gonna have to check them one at a time. It's a bit of a pain. Typically, a question will ask you to check for any two nodes actually. All right, so let's get started with T and B. We know that two nodes are d-separated, and that means that they are independent of each other. इन एक्चुअल जो आपके पास डेफिनेशन है स्लाइड्स के अंदर भी, दिस इज हाउ यू चेक टू नोड्स आर डी सेपरेटेड इफ एंड ओनली इफ either there exist no paths between them or all paths between them are blocked by a collider. All right, so हम T and B के लिए चेक कर लेते हैं. The thing is कि T से directly एक arrow B पे जा रहा है, which means that they will not be d-separated. No, since there is a direct path from T till B. I hope that that is clear. Are there any questions?
No.
Okay, let's check for T and C. T and C के साथ भी यही issue है कि एक direct path है between T and C, which means that obviously they cannot be independent of each other. One is
नो
causing the other to
डायरेक्ट
happen.
यस
Sorry, yes?
मैं मेरे ख्याल से टी एंड सी में कोई डायरेक्ट बात नहीं अच्छा वो
This one, C
ओके
से एक arrow directly T को जा रहा है ना?
ओके ओके सॉरी
Okay, then we can look at D. D के साथ भी यही issue है कि T से एक arrow directly जा रहा है, which means that they cannot be independent of each other. Lastly, you have E. Are T and D independent of each other? Are they d-separated?
नो
Why not?
बिकॉज टी गोज टू डी गोज टू ई
Perfect. So ये एक path open है between them. T goes to D, goes to E. Interestingly, एक और भी path open है.
और टी टू बी बी टू डी एंड डी टू ई
Oh my bad, तीन paths open है. ये C वाला भी open है in fact.
सी टू डी फिर तो एक और हो जाएगा ना साथ सी
Yeah, three paths open है. T से D से E तक वाला path open है, and then T, B, D, E is also open. And ये जो fork वाला path है, or common cause वाला C to D, T and C to E ये भी open है, because we know कि अगर like दो nodes के बीच में एक fork exist करता हो, तो वो independent नहीं होते. Like this one, see? So because of all three paths, ये d-separated नहीं है. Are there any questions?
नो
Okay, let's check for B and C then. Are B and C independent of each other?
लेट्स सी बी एंड सी
Yeah.
नो
No, why not?
because C goes to T and T goes to B.
Perfect. This path is open. C goes to T and T goes to B. Since अगर एक भी path open हो तो nodes independent नहीं हो सकते. They can't be d-separated. All paths have to be closed or no paths should exist to begin with. Okay. Next you have B. So what about B and D?
Direct path है.
Yeah, there's a direct path between them. So ये भी d-separated नहीं हो सकते. Next you have B and E.
B and E
Yeah, they can't be deseparated either because this path is open essentially. Can you tell me which one?
B to D to E.
Yeah, B to D to E essentially. एक और भी path open है in fact.
Uh,
एक्चुअली
from B to E.
मल्टीपल और ओपन पाथ्स बन जाते हैं लेकिन एक ये वाला है जो BTDE है because T is just a fork, right? And a fork
Hmm.
keeps the path open. Similarly, अगर मैं BTCE से जाऊं तो वो भी path open है because C is a fork. So I'm just gonna write this down. We're not gonna state each of those paths. Um, then next you have C and D. Are C and D separated?
C and D, no.
No, how come?
C to T to D.
Yep, that's right. So C से T से D पे path जा रहा है. I don't know if other paths are open or not. We're not gonna get into that right now because the rule is कि आपको कोई एक भी path open मिल जाए तो you don't have to look at any others then because then they can't be deseparated. What about C and E? Oh, again, no, there's a direct path between C and E. Lastly, you have D and E. D and E can also not be deseparated since इनके बीच में भी direct path exist करता है. So this means कि इस पूरे graph के अंदर there are no deseparated nodes. Are there any questions?
No.
All right, okay. So ये part B नहीं है, ये part C है. But before that, let's just write the answer down over here. No nodes are deseparated by default or without any conditioning. Then there is conditional deseparation. If we are clear about deseparation, so this is not that hard to grasp because अब आप ये कर रहे हैं कि आप किसी नोड को या किसी set of nodes के ऊपर आप condition कर रहे हैं and then you are checking if they are deseparated or not. Let's look at these structures for instance. Chain के अंदर अगर मैं B पे condition करूँ तो A and C will become deseparated because they will become independent if I condition on a mediator, right? Similarly, fork के अंदर अगर मैं B पे condition करूँ तो A and C will become deseparated. Collider के अंदर A and C are already deseparated by default, but if I condition on B, I will accidentally open this path, making A and C not deseparated any longer. Does that make sense?
Yes.
Okay, great. So we will keep this methodology in mind. इसका ये मतलब नहीं है कि हर fork के ऊपर condition करना important है या हर collider के ऊपर आप conditioning avoid करते हैं. We'll look at this through an example. One important thing to keep in mind over here is कि I'm just gonna open these slides over here real quick because I want to reiterate this once. Otherwise, it's a slightly confusing concept. Yeah, it's in lecture 15. Yep, here we go. So for conditional deseparation, two nodes are going to be conditionally deseparated on another node B or on a set of nodes B if either they are deseparated by default um, और उससे कोई path open नहीं होती or all undirected paths containing them connecting them contain B as either a fork or a chain but not as a collider. यहाँ तक हम discuss कर चुके हैं कि chain या fork के ऊपर अगर आप condition करें तो the nodes will become deseparated but collider पे आप condition नहीं करते. The other important part of this is कि आप collider के descendant पे भी condition नहीं करते. अगर collider के descendant पे आप condition करें तो it gives you some information about the collider, hence partially blocking the collider or fully blocking the collider. And you know, when you block a collider, then those nodes are not deseparated anymore. Does that make sense?
Yes.
Yeah, we will look at this through an example for sure as well. Lekin I think yeah, is question में this doesn't apply, but we will look at another question right after this one. सो आपने एक नोड के ऊपर कंडीशन कर दिया विच मीन्स के उसकी वैल्यू को फिक्स कर दिया। जिस नोड पे कंडीशन किया है उसको मैं हाईलाइट कर रही हूँ टू मेक थिंग्स मोर एविडेंट फॉर अस। अब इसकी वैल्यू फिक्स्ड है टी की, विच मीन्स के आई कैन नॉट चेक फॉर टी टू बी डी सेपरेटेड विद एनी अदर नोड, राइट, बिकॉज टी इज फिक्स्ड नाउ। सो ये वाले सारे कॉम्बिनेशंस मुझे टेस्ट करने हैं essentially. So now this is blocked and let me try it out now. So if I have to check for B and C, are they deseparated or not? The rule is I have to check all the paths between them. एक ये path है जो इस तरह से follow कर रही है essentially. I will just list all the paths over here one by one. You have C, it goes to T, and then that goes to B. इसमें T is acting as a mediator or a chain, right? And इसमें मैंने T पे condition कर दिया, which means कि this path is blocked now. Next we have to look at any other paths that remain. उसके अलावा एक ये path है, the one that goes from C to T, and well then from T to D essentially, and ये डायरेक्शन है। डज दिस पाथ मेक सेंस? ये वाली पाथ मैंने लिखी है essentially because I have to list all the paths one by one. Is this path blocked or is it open? That's my question. क्योंकि एक इसमें यहाँ पे collider exist करता है और एक fork था जो कि blocked है. So what do you think? Is
तो
this
आपने
path blocked or
फोर्थ
not?
को तो कंडीशन कर दी है ना, तो वो तो फिर इंडिपेंडेंट हो गया डी के साथ।
अच्छा, the thing about a path like this is कि जिस path में collider exist करता है वो path already blocked होती है। सो ये वाली
ओके।
पाथ पहले से ब्लॉक्ड थी। अगर इस पाथ में मैं डी के ऊपर कंडीशन कर देती तो ये पाथ ओपन हो जाती, बट मैंने टी पे कंडीशन किया है विच इज एज गुड एज डूइंग नथिंग। सो टी पे कंडीशन करने से कोई फर्क नहीं पड़ता, दिस पाथ वाज ऑलरेडी ब्लॉक्ड, इट्स गोना रिमेन ब्लॉक्ड, बिकॉज हमने स्लाइड में ये देखा कि conditioning on a collider or the descendant of a collider opens this path. But T is not a descendant of this collider, is it?
नो।
Yeah, so this path is already blocked. Does that make sense? In my process, I'm trying to ensure that all paths are blocked. So मैंने दो paths check कर ली. I'm gonna check the next one now. Next, I think that this is the only path that we can form right now. It starts at B and then D, then E, and then C. Is this path blocked or not?
दिस इज अ कोलाइडर, तो दिस इज ब्लॉक।
या परफेक्ट, इसमें एक कोलाइडर एग्जिस्ट करता है तो ये पाथ ऑलरेडी ब्लॉक्ड है। सो हमने सारी पाथ्स चेक कर ली बिटवीन बी एंड सी एंड ऑल ऑफ देम वर ब्लॉक्ड, no path was open between them, which means that these are d-separated nodes B and C conditioned on T. Are there any questions so far?
नो।
Okay, so what about B and D? Are they d-separated conditioned on T?
नो, देयर इज अ डायरेक्ट पाथ।
Yeah, you're absolutely right. Perfect. No, since there is a direct path still, जिसको आप ब्लॉक कर ही नहीं सकते। अगर डायरेक्ट पाथ एग्जिस्ट करता है तो आप बाकी नोड्स पे कंडीशन करके भी ऑब्वियसली उस डायरेक्ट पाथ को नहीं ब्लॉक कर सकते। नेक्स्ट यू हैव बी एंड ई, आर दे डी सेपरेटेड कंडीशनड ऑन टी?
नो, चेन है।
Yeah, perfect. No, because this path is gonna remain open essentially. इसके अलावा भी कोई पाथ ओपन है क्या? आई थिंक कि ये बाकी पाथ्स जो भी टी से गुजर रही हैं वो तो ब्लॉक्ड है। सो इट डजंट मैटर, once again the rule is कि as soon as you find even a single open path you don't have to look for any others, because even if one path is open they can't be de-separated. Okay, so we have C and D. Are C and D separated conditioned on T?
डी एंड सी।
Yeah, एक तो
यस,
ये
दे आर
पाथ एग्जिस्ट
सेपरेटेड।
करती है। They are de-separated? Okay, great. Let's check. पहली ये पाथ एग्जिस्ट करती है जिसमें टी इज अ चेन और आपने कंडीशन कर दिया, सो दिस पाथ इज ब्लॉक्ड। दूसरी एक ये वाली पाथ एग्जिस्ट करती है जिसमें वंस अगेन टी इज अ चेन और आपने इसको भी ब्लॉक कर दिया, या दिस इज ब्लॉक्ड। The third path that exists is essentially this one, E. इसमें E is a collider and colliders वाली paths are already blocked by default. So I think that means कि सारी paths blocked हैं।
Yes.
ये वाली by default blocked थी और उससे पिछली दोनों हमने खुद block कर दी, which means that yes, they are deseparated, conditioned on T. What about C and E?
C and E
No.
direct path है.
Yeah, there's a direct path between them. What about D and E?
D and E
No, no,
direct path.
D and E.
Direct path है.
या इनके बीच में भी डायरेक्ट पाथ है essentially. So this means कि after conditioning on a node P, सिर्फ ये दोनों nodes, ये दोनों sets हैं जो deseparated हैं, B and C and D. So let's state these over here. B and C and D. So ये दो sets हैं जो deseparated हैं. अब B and C and D, nothing else. We've checked all of them. Are there any questions so far?
No, not from my side.
Okay, great. With that, we're gonna look at the backdoor criterion. Backdoor criterion को हम use क्यों कर रहे हैं? Now we're at a stage where we want to estimate the true total effect of one node on another. And we want to see कि वो effect estimate करने के लिए किन nodes पे condition करने की ज़रूरत है to block any spurious correlations, और किन नोड्स पे कंडीशन करने की ज़रूरत नहीं है, किन नोड्स पे कंडीशन करने से एक्चुअली गड़बड़ हो जाएगी. सो लेट्स सी, इन अ चेन वी नो कि अगर ए का सी पे ट्रू इफेक्ट मेजर करना है तो आप बी पे कंडीशन नहीं करते, अदरवाइज यू विल ब्लॉक पार्ट ऑफ द फ्लो ऑफ कॉजल एसोसिएशन बिटवीन ए एंड सी. Similarly, well, when you have a fork, तो you do condition on B, क्योंकि अगर आप B पे condition नहीं करेंगे तो you will not block the flow of this spurious correlation between A and C. In a collider, you don't condition on anything, क्योंकि अगर आप condition कर दें B के ऊपर तो you're gonna introduce a spurious negative correlation between A and C, which essentially just means कि एक fork को block करना होता है. Um, so what we do is essentially कि we identify all backdoor paths between two variables. The reason for identifying backdoor paths instead of just directly conditioning on all forks will be made clear to you shortly. बैकडोर पाथ होती क्या है? एक बैकडोर पाथ को हम इस तरह आइडेंटिफाई करते हैं. लेट मी सी इफ दिस हैज बीन stated for you somewhere here as well. It hasn't, or rather, I can't find it right now. So, a backdoor path is just a path जिसके start में और end में arrow treatment के भी अंदर जा रहा होता है और outcome के भी अंदर जा रहा होता है. Oftentimes, this is confusing for students even up until the very end. But I'm gonna make this very clear to you right now. A backdoor path is a path जिसमें स्टार्टिंग नोड के अंदर इस तरह एरो जा रहा होता है, बीच में देयर कुड बी एनीथिंग, एंड देन एंड में इस तरह एरो आउटकम नोड के अंदर जा रहा होता है. दैट्स इट, इट्स रियली सिंपल एक्चुअली. दिस इज हाउ यू डिफाइन अ बैकडोर पाथ. In order to apply the backdoor criterion to estimate the true effect of one variable on another, you identify all the backdoor paths between them, and then you check कि इनमें से कौन सी backdoor paths blocked है और कौन सी block करनी important है, but we'll get there in a bit. First, let's look at our question. What variables do we condition on in order to find the true total effect of T on E? इसको यहाँ पे copy कर लेते हैं. Okay, T का E पे आपने effect find करना है, which means that the first step is to list all backdoor paths between T and E, which is really simple now that we know what a backdoor path is. So I will pause over here for a few seconds and wait for you guys to identify any backdoor paths. Timur, do tell me if you're able to find any. क्योंकि लेट्स बी माइंडफुल, हम टी एंड डी के बीच में सारी पाथ्स ऊपर शुरू में ही लिस्ट कर चुके हैं.
So I guess we have the non-casual path as a backdoor path.
या दैट्स एब्सोल्युटली राइट. इसका ये मतलब नहीं है कि हर नॉन कॉजल पाथ एक बैकडोर पाथ ही होती है. बट ये वाली नॉन कॉजल पाथ इज डेफिनेटली अ बैकडोर पाथ बिकॉज टी के अंदर भी एरो जा रहा है एट द स्टार्ट ऑफ द पाथ, और ई के अंदर भी एरो जा रहा है एट द एंड ऑफ द पाथ. So this is the only backdoor path. Let's list it over here. The second and the final step is to check um, if any backdoor paths are open. If yes, block them. And how do you block them? You block them by conditioning. All right. Is this backdoor path open or not? Of course, this backdoor path is open. ये blocked नहीं है. Blocked वो वाली paths होती हैं जिनमें colliders exist करते हैं. इस path में there is no collider. There is just a single fork, which means that it's open. So what do we need to condition on then? You need to condition on C to block this path. So this is the entire backdoor criterion essentially. आप find करते हैं उन nodes को और आप condition कर लेते हैं उन nodes को. Once again the same criteria follows. इसकी हम where did I इसकी हम slide देख लेते हैं. So the thing is कि oh yeah, this is where a backdoor path is stated, by the way. The exact same thing that we just discussed right now. So t and y will be deconfounded. You have to remove the effect of any confounding variables in order to estimate the true total effect of t on y. So they will be deconfounded if you block every backdoor path between them. If a backdoor path is already blocked, so you don't have to do this at all. How do you block a backdoor path? You control for some set of variables. But during the process of controlling, this is one thing that you have to make sure of. No member of Z is a descendant of T on a causal path. Because if that is true, तो आप उस causal path को भी block कर देंगे essentially. I feel like an example for this should help. If you have something like this, let's say A goes to B, sorry, my bad. I intended to make one with a fork in it. So अगर मैंने A का E के ऊपर impact measure करना है, तो what node will I condition on? Because this is a backdoor path, right? So the interesting thing is कि backdoor path block हो जाती है by conditioning on any one variable in that path. Ideally, I would just condition on my fork and I would block this path. But अगर मैं C पे condition करूँ तो भी ये path block हो जाएगी. Now, this is the interesting thing actually. If I have something like this, D, and then D का arrow C पे जा रहा है, so can you condition on C then? Is conditioning on C going to be appropriate? Let's look at this once again. No member of the nodes that you are conditioning on should be a descendant of T on a causal path. The thing is कि एक ये वाली causal path है जिसके अंदर C is a, हम इसको एक्चुअली चेंज कर देते हैं ताकि ये टी वाली कन्वेंशन के साथ ही कंसिस्टेंट हो जाए एंड वी रिमूव एनी कंफ्यूजन. या So this is essentially the problem. This is a causal path जिसमें C is a dependent of T. So while conditioning on C will block मेरी ऊपर वाली backdoor path, at the same time it will block the flow of causal association from T till E, since C is a mediator in that path, right? And we don't condition on mediators. So this is the concept that we were talking about in the slide. आप C पे condition नहीं कर सकते to block this path, which means that the only way to go about this is to actually condition on B. Are there any questions? All right, so this is one very important concept that I wanted to iterate. On that note, we're gonna move on. For just this question, हमारे पास ये एक ही backdoor path थी और उसमें obviously there was just one node that we could condition on. So we blocked this path. After blocking this, you can estimate the true effect of T on E. Let's move on towards our second question. I've already copied it here, but just to show you the graph that we're working with as well. This is the new graph that we're working with. First, you have to identify all the causal and non-causal paths from X till Y. So I will pause over here and give you guys a few seconds to figure this out. Okay, do we have an answer for causal paths between these two variables?
I guess no.
No causal paths between them? Yeah, you are right. None. What about non-causal paths?
Mm, A to X and A to Y.
Perfect. ये A वाली path is non-causal. एक और path है.
I guess X to B, C to B, and C to Y.
All right, perfect. हमारे पास कुछ deseparation के questions हैं. Even though this is the last part, it's part E. But एक दफा हम इस part को पहले जरूर देख लेते हैं, since this is a fresh concept. What variables should we condition on to observe the true total effect of x on y? So x का y पे impact measure करना है. The algorithm that we're using is the exact same. First, you will list all backdoor paths between them. So, what are the backdoor paths between these two variables?
Only the first known causal path.
Yeah, you're right. Only the first non-causal path is a backdoor path between them. Which means कि what nodes would you condition on?
A.
Perfect. Condition only on A. So this is what I was talking about कि हर जगह हम condition नहीं करते fork के ऊपर. C ये जो दूसरी वाली non-causal path थी, इसमें C was a fork, but this wasn't a backdoor path to begin with. उसकी वजह ये है कि इसमें collider भी है, which means कि ये path blocked है by default. It could have been possible, in fact, कि एक ऐसी path भी exist करती. Suppose there was a node over here. अगर यहाँ पे node होता तो फिर this would have been a backdoor path. Then would we need to condition on anything in this path?
Uh, uh, can you please repeat that part?
Yeah, मैं कह रही हूँ suppose करें कि इस path में एक ये चीज भी exist करती. Just for the sake of an example. तो अब
Hmm.
ये एक backdoor path बन गई है, right? Oh,
Yes.
sorry, I meant to just copy it. तो अब मुझे इस बैकडोर पाथ में किसी नोड पे कंडीशन करने की जरूरत है क्या टू ब्लॉक इट? ऊपर वाली को तो मैंने ब्लॉक कर दिया बाय कंडीशनिंग ऑन ए, व्हाट अबाउट दिस वन?
इसमें आप किसी पे भी कंडीशन कर सकते हैं क्योंकि कोई भी जो नोड है वो कॉजल पाथ में नहीं आ रहा।
हाँ, I see. So this is the confusion that I wanted to clear. The thing is कि ये एक backdoor path जरूर है, लेकिन as per our algorithm we check if any backdoor paths are open. अगर open हो तो फिर हम उन पे condition करते हैं. ये वाली path तो already blocked है because B is a collider in this path. इसीलिए हमें किसी भी नोड पे condition करने की जरूरत नहीं है in this path. Does that make sense?
यस।
ऑलराइट, परफेक्ट। इट मीन्स कि लाइक आप किसी नोड पे कंडीशन कर भी सकते हैं। ऑब्वियसली अगर बी पे कंडीशन करेंगे तो पाथ ओपन हो जाएगी, दैट वुड बी बैड। विच मीन्स कि इस पिंक नोड के ऊपर या सी के ऊपर आप कंडीशन कर भी सकते हैं, बट इट्स नॉट ऑफ एनी यूज टू यू, इट्स जस्ट अ वेस्ट। अगर बी पे कंडीशन करेंगे तो गड़बड़ हो जाएगी। इस नोड पे या सी पे कंडीशन आप कर सकते हैं, बट इट्स नॉट नीडेड। Typically, a question will ask you to state the minimum set of nodes that you need to condition on in order to determine the true total effect of one variable on another. और जब आपको minimum set कहा जाएगा तो उसमें if you add a node like C or this pink node जिस पे condition करने की ज़रूरत नहीं है, तो then that would be incorrect essentially. So you're only going to condition on A regardless. Are there any questions so far?
नो।
ओके, ग्रेट। अब हम डी सेपरेशन वाले कुछ क्वेश्चंस देख लेते हैं। आई एम एक्चुअली जस्ट गोना कॉपी दीज हियर। इसका आंसर यहाँ पे लिख लेते हैं। वी विल कंडीशन ओनली ऑन व्हाट नोट डिड वी डिसाइड? ए।
ए।
या, थैंक यू। वी विल कंडीशन ओनली ऑन ए। सो ये वाले पार्ट्स कॉपी कर लेते हैं, ये सारे ही डी सेपरेशन वाले हैं एसेंशियली। All right, great. So I'm just gonna put these here. And let's go through these one at a time. First, are x and y de-separated or not? X
नो।
and y की हम बात कर रहे हैं। No, why not?
बिकॉज ऑफ ए फॉर्किंग।
No, you're absolutely right. Since this path is open, इसके अलावा भी कोई path open है क्या?
नो। उसके अलावा तो एक कोलाइडर है।
Yeah, you're absolutely right. इसके अलावा कोई path open नहीं है। Let's move on to part C then. इसका मतलब है by default they weren't de-separated. So are they de-separated conditioned? अब ये part ही आधा गायब हो गया है. So I'm just gonna look at this from here on A and C. So अब हमने इन दो nodes पे condition कर लिया. Are they gonna be de-separated now? X and Y de-separated conditioned on. Let me just highlight the nodes जिन पे condition किया है. इन दो को block कर दिया. Think about it.
यस आई गेस।
Yeah, that's true. They are de-separated now. And why are they de-separated? Because ये नीचे वाली path तो already blocked थी, C पे condition करने से ये obviously open नहीं हुई। And A पे condition करने से ऊपर वाली path भी block हो गई essentially. Let's look at part D then. Are they de-separated if you condition on A and B instead? इसको remove कर देते हैं और हमने इस पे साथ condition कर लिया. What happens now? Once again, do think about this.
दे आर नॉट दे आर दिस दे आर नॉट डिसेपरेटेड।
They're not deseparated. You're absolutely right, actually. But why are they not deseparated?
बिकॉज एक्स एंड सी का पाथ ओपन हो जाएगा जब आप बी पे कंडीशन करेंगे.
Excellent. It's gonna be open now क्योंकि जब आप कोलाइडर पे कंडीशन करें तो जो ब्लॉक पाथ होता है वो ओपन हो जाता है. So no, since this path is opened now, B and C and Y. So collider पे condition करने से path open हो जाता है. Which takes us to our last part for causal graphs. Are they deseparated conditioned on A and D instead? अब मैंने B पे नहीं condition किया, D पे condition कर लिया है.
दे आर डिसेपरेटेड.
No, that's incorrect actually. But I don't blame you. This is a slightly tricky question. This is often confusing for students. अब हम एक deseparation के concept को फिर से revisit कर लेते हैं. Let me see. Yeah, here we go. So conditional deseparation में ये एक चीज लिखी हुई थी, which I said I would reiterate as well. But not as a collider or a descendant of a collider. So हमने collider पे तो condition नहीं किया, लेकिन D was a descendant of that collider, right? So अगर आप collider के descendant पे condition करें, तो the thing is कि it gives you some information about the collider as well, thereby kind of, blocking the collider, which is essentially equal to opening this path. Does that make sense?
यस.
Okay, so no, since this path is once again open now. पहले open हुई थी because of conditioning on a collider, अब open हुई है because of conditioning on the descendant of a collider. So that's actually all as far as graphs are concerned. Are there any questions before we conclude?
नो.
All right, that's gonna be all from my side then. Are there any other questions? Shall I wrap up this meeting?